And now I share the screen for all the students who connect to our meeting online. I think you can see it. I don't want to expand it on the full screen because the resolution of this screen and the resolution of the projector is different. Well, on the previous lesson, we discussed that we are going to study programming, and the programming language that we will consider, it will be C. C first semester and C++ second semester. But from my point of view, there is no difference between C and C++. So first semester we study fundamentals of C++. Next semester we will study some special features of C++. But how to develop a program? The general question. It doesn't depend on any concrete programming languages, any concrete programming language, but the general scheme of program development is more or less the same for any language. Java, Python, C#, Fortran, SQL. We can take any language, but the general scheme of the program development will be the same for any language. I can select any language. This scheme will be more or less the same. And what we will see on the screen. This is the entry point, the start of the program development. And first, what we should do. I show you this example on previous lesson. First, we should prepare the text of the program. And the text of the program can be prepared formally with the help of any text editor, any kind of text editor. But of course, it's more convenient to use the editor from the development environment, from Visual Studio. Well, we prepare the text. Then, when we have the text of the program written in some algorithmic language, and also I show you, I can show you again when I start Visual Studio, and when we create a project, when you create a project, Visual Studio allows you to select the language. And there are a lot of languages that are supported by this development environment. So this algorithmic language can be C, BASIC, and Python, any other language that is supported by Visual Studio. Then, when you write the program, with the help of compiler, we prepare program compilation. We start the program compilation. And I show you this on previous lesson. Compiler, in the case when the program is wrong, outputs you their messages. Is the program correct or not? If your program is not correct, if there are some errors, in this case, we go this branch, and again, we should correct the program. With the help of text editor, we should rewrite it. This correction may be small, this correction may be large, but we should correct it. After that, we must recompile it. We must recompile the program, check again the messages from the compiler, and if it still be errors, we should correct the program again, and again, until the program becomes correct, until the compiler outputs you the message that program. I don't remember this message in English because here there is a Russified version of Visual Studio. Maybe succeeded, compilation succeeded, no errors. If this process, if the compiler outputs you the message that there is no errors, it means that compiler builds the executable file. The file that contains the so-called machine code. The code that can be executed by the processor, by the central processor, because the program that you write, it cannot be run directly on processor. Compiler must build some executable code. And after that, development environment launch this code on a central processor, CPU, and execute the program. The program requires some input data. According to the general scheme of data processing, any program requires input information and it has output information, result. And this input, this initial data is input of the program, and the program has output results. But in some cases, when you run the program, during this process, you can get the message that there are some execution errors, not compilation errors, but execution errors. So compiler builds the program correctly, but when you try to run it, this time you will have, you get the message. And in this case, if there are some execution errors, you should go back. Again, here, you should correct the text of the program. You should recompile it and run your program again. Okay, imagine that there are no system messages. There are no execution errors. In this case, we should analyze the output results, because the typical situation is that you run the program works, you enter the correct input, you enter the correct initial data, but the result is wrong. The result is wrong. And in this case, we should again correct the program text of the program. We go back here, we correct the program, we recompile the program, we start it again, and we check the result. And only if the result seems to be correct, we can say that the program is developed. We finish the process of development of the program. On the previous lesson, we consider some simple example of data processing, computing the average value. And on this simple example, it's very simple to show how to check are the results correct or not. Yes. Do you remember the task? The task is to compute the average temperature. Yeah? Suppose that we measure the temperature during the day. We have these results of measurements, temperature number 1, temperature number 2, temperature number 3, and so on, temperature number n. And we should summarize all of these temperatures, divide it over n, and we obtain the average temperature. And okay, this is the so-called toy example, but it's very good. I can suppose that we measure the temperature, and I know that the temperature is positive. All of the day it's positive. It will be positive. For example, 15 degrees, 17, 20, 10, but it's positive. But the average, you get negative. This is a very simple. It's just imagine that your program answered that the average is negative. It seems that the answer is wrong. It's just an example how to check. It's very simple to check. In many cases, it's very simple to check is the result wrong or not. In general, if your program answers that the temperature is negative, it's wrong. It's wrong result. You should correct the program. Of course, if, for example, the real, imagine again that the real average temperature should be something like 18.5, but your program answer that the average temperature is 18.6. Of course, this result you cannot check. You cannot check. So simple. But if your program answer that the result is -1, of course, this result seems to be wrong. It's just an example. And again, let me remind you how to launch the project. We should start Visual Studio. We should select. Yeah. Yes, you can, but I continue the lesson. Okay. We should create a project. This button. Select console application. This first. C++ here, and this item, console application. After that, Visual Studio shows you the default name of the program, default name of the project. Just create. And you will see the simple program. Visual Studio creates you the simple program that just outputs to the screen the message, hello world. This program doesn't have any input. This program has only one output. It just outputs the message. So it will be correct in any case. Just outputs the message, hello world. Well, and from this lesson, we step by step, we will study C language. We will study how to write such programs. Let me switch to another presentation. beginning of the C language. And again, this presentation, I start with a very, very brief review of the history of C language. Well, in the end of the 70s, the employees of the Bell Laboratories company, Dennis Ritchie and Ken Thompson, created the C language during the joint work at the operating system Unix. And if you type these two names, I don't include the photo of these persons, but if you type these in Google, let me start Google Chrome. Let's type Dennis Ritchie and Ken Thompson. You will see a lot of pictures of these two guys. Classical picture of two programmers. But I think nowadays they look like this. They look like this. Dennis Ritchie and Ken Thompson, the authors of the C language. This is one more picture. Well, and yeah, history of computers. You can see how the computer looks that years. Not a personal computer, but computer requires a large room to be installed. By the way, there is some kind of joke. What is the definition of a supercomputer? How to define supercomputer?
Smart.
Not smart, super.
Fast.
You can say fast, yes, but 50 years ago, this computer can be considered as a supercomputer. That years, this computer was fast, but nowadays it will be extremely slow. But small? No. Oppositely, no. Supercomputer is a big computer. Computer that requires one room to be installed. to be installed. And that days, it was supercomputer. But just a remark that in our university, we have a supercomputer. I can show you the picture of this computer. Wait a minute, I just open the photo. Yeah. This is a picture of our supercomputer, Lobachevsky. And you see that this supercomputer also requires one room to be installed. It's not a personal computer, it's installed in another building, and we have access through internet to this computer. Nobody works here in this room. We just send the program, and the program executes, and after that we get the data. But let's compare this picture and this. You see that computer the powerful computer is big in any time. That time, this computer was big, and nowadays, powerful computers are big. This is the personal computer, and the definition that supercomputer is small. No, personal computer is small, but supercomputer is big. Okay, let me switch back to morning. You remember what time our lesson should start or not? Just to be sure, you remember or not?
I remember. Now
you remember. You remember. Excellent, excellent that you remember. Well, and C language didn't appear from anywhere. It has some prototypes. For example, language B, language BCPL. And C language, it was elaborated as a tool of practical work of programmers. And the main goal that Ritchie and Thompson implement in C was the creation of convenient and useful language. And this language is oriented for practical work of programmers. Because the days there are other languages that still be nowadays too, that have another goals. For example, Pascal was oriented at theoretical completeness of language constructions. BASIC was oriented for beginners, for easiness of use. And nowadays I can say that Python is also oriented for easiness of using the language, because it's more simple to write the program in Python that in C. And Fortran is oriented for scientific computing. The name of this language is just abbreviation, formula translator. But C is oriented for practical work. Let's briefly consider some advantages of C language. First, C is a contemporary language. It means that it includes the control constructions which are recommended in theoretical and applied programming. Its structure is oriented at applying such programming technologies as downgoing design, structured programming, step-by-step module development, and in C++, also object-oriented programming. C is an efficient language. Its structure allows to use the resources of computers in the best way, and C programs are usually compact and fast. It will be useful to compare from this point of view different languages. When I say that the program is fast, I mean that suppose that you write program in Python and in C, in Python and on C, and we compare the speed, how it works, and the program written in C will be much faster than the program written in Python. But maybe the program in Python will be shorter. because some actions can be implemented in Python very, very short, just one line in Python. And for example, when you write program in C, when you write C program, you should write 5 or 3 lines of code to do the same. So usually a program written with Python is shorter, but is much slower. From another point of view, C is not maybe very is not the fastest language. It means the program written C may be not the fastest. If we use a lower level programming language, assembler, the program written in assembler can be faster, but it's very hard to understand such program. It's very hard to write. It's very hard to support this program. Next feature of C language, that C is a portable language. It means that the program written in C for one computation system may be transferred to another system just with small changes. So here, this class, we develop program under Microsoft Windows using Microsoft Visual Studio. But if you take the text of the program and copy this text, for example, on another computer under operating system Linux and another development environment, for example, Line or Eclipse, and run, this program can be compiled and can be run maybe just with minor changes or with no changes at all. It means that you can compile and run the programs written in C on different platforms, different operating systems, using different compilers. There are a lot of compilers. According to this scheme, compiler is just a special program that takes the source code, the text of the program, and builds the executable file. And compilers are implemented in any operating systems. And when compiler gets their text of the program, they can build it can build the executable file, and it can be done under any operating system and any computers, from personal computer up to the supercomputer. And by the way, it's a general scheme of program development. When you develop the program on personal computer, yeah, you develop the program on personal computer, and after that you send it on supercomputer, run it on supercomputer, and get the results. Well, C is a powerful and flexible language. For example, the most part of the operating system was written in C. And now this language is used for solving the wide spectrum of different problems. I can maybe I just type just example. just open the page. Oh, it's not, sorry, it's not top. It's a video. I think that, yeah, a lot of applications, a lot of programs. Yeah, top best applications written in C and C++. Yeah. Adobe Photoshop, Google, a lot of applications for Android, Mozilla Firefox. All of these applications are written, and tens of thousands other applications, tens of thousands other programs. Well, and I can say that C is a comfortable language. It means that on one hand, it provides for good programming style, and on the other hand, it's rich enough to implement the program in a creative way. It means that you can write rather short constructions that implements rather complex algorithms. Again, of course, some other languages maybe allows you to write more short constructions, more short statements like in Python, but Python is a slow language. Well, and when we discuss about programming language, it of course not very close, but more or less similar to natural language, English, Russian, French. So like we have different natural languages, we have different programming languages, and like natural language has its own alphabet. Programming language also has its own alphabet. So we have set of symbols, and using these symbols, we construct so-called the words of the language. Like we use English letters to construct the words in English. For German, we have some other alphabet. For Russian, we have Cyrillic alphabet, and so on. And actually, these set of symbols is written in some special table, and it contains the Roman letters, uppercase and lowercase, digits. In Russia, we call these digits Arabic digits. I know that in other countries, these digits 0, 1, 2, 3 is called some other. But in Russia we call it Arabic digits. In contrast to Roman digits, and some special and control symbols. Of course, you should not remember all of these symbols. Just I want to show you that C alphabet includes all the uppercase letters from A to Z, all lowercase letters from A to Z, all the digits from 0 to 9. Well, very important special symbol underline. It's not a space, it's underline. This symbol, this one. It's not empty space, it's a symbol that underline. Well, symbols for mathematical operations. It's usually used plus, minus, star, and so on. Symbols that corresponds for comparison, that we use for comparison, less than, greater than, and many other special symbols that have their own meaning. I don't want to consider the meaning of each symbol right now, but on the following lessons, we step by step consider all the meaning of each symbol. In this table, you may find any symbols that are included in the alphabet of the C language, and also empty space. The space is also included in the alphabet. A lot of symbols you can find here on the keyboard, but not all the symbols in the keyboard are included in alphabet of the C language. And using these symbols, using the alphabet, we construct the words of the language, so-called lexemes, the words of the language. And using these words, we construct the sentences, just like in natural language. We write the sentence using a word. In programming language, we write some statement, for example, computational statement or input-output statement using lexemes. For example, this statement is an output statement. It's a one complete sentence of C language. Well, and the structure of the C program. The program, in general, can be divided into several parts that are called subprograms or functions. And one of them is called main, the main function. And this function implements all the program as a whole using other subordinate or slave functions for performing subtasks. The functions are optional. You can write the program without subordinate function. But the main function is obligatory. And in the simplest case, the program contains only one function with the name main. So this is the simplest case. The program contains only main function, but it must be the function with the name main. If you type another name, for example, I already show you this. Suppose that I try to run this program. Now this program is correct, and if I press this button and run the program, I see the message hello world. But suppose I write here another name, not main, but main1. It will be wrong. And if I try to run the program, compiler outputs a mistake that the program is wrong, because the program must contain only the one and only one function with the name main. But in general, the program can contain several functions before main and preprocessor directives before the functions. In this case, usually we should write at least one directive, include IOStream, and also for simplicity, it's better to write here another directive using namespace std. And when you write this directive, in this case, you should skip this prefix and write just cout and the message. And we see hello world. So in this case, two directives, no subordinate functions, and the main function that outputs the message to the screen. This is an example of another program. It contains, it's not so simple like just a message to the screen. It contains some computational statements. It contains a declarative statement, the loop, and so on. I want to show you the main points here. There again, that this program contains directives. This program contains the header of the main function, the main program, and the body of the main function that included between the brackets, open and close brackets, open brace and close brace. Okay. Let's consider very briefly some basics lexemes of the language. We see, I show you this table that contains all of the symbols that are included into the alphabet. And some of these symbols can be considered as a separate lexeme, so-called separate word of the C language. The best example is arithmetic operations, for example, plus, minus, addition, subtraction, division, multiplication. If I write these symbols are used for naming the operations: addition, subtraction, multiplication, division. This operation, this sign has a different meaning. It's not a, yes, it's percent sign, but it's not, it doesn't mean percent in our real life sense. It has another meaning. We discuss about it later. It's just because it's used also in computational operations, but it has another different meaning. But these signs have the same meaning: addition, subtraction, multiplication, division. The equal sign denotes the assignment operation. For example, these symbols I skip. It's a logical operation. We discuss about it later. These symbols are used for comparison, to check less than or greater to compare two values, and so on. And some symbols that are written in pair, they form another lexeme, another word of the sentence. Later we discuss about it. Some lexemes, some words are intended for notation, for designation of language statement and structural parts of the program. For example, data types, directive names, and so on. Such words are called reserved or keywords. And these words can be used only in predefined sense. Here we may see the examples of these reserved words: include, return, int. We consider it in details later. It's just an example. And I want to show you that when you write reserved words, Visual Studio indicates it with a blue color. For example, 4, right? Or maybe not, yes, this or this. Different color, different, not black, but some another color. For example, static, blue. So it indicates with, of course, it corresponds, it depends on the of the color that you select. Here it's a white color. Maybe you prefer to change the color. Change the color if you. I want to show you. Yeah, you can. Sorry. Just an example for you. If you select here project parameters, editor. Okay, I forget where is it. I want to show you how to change the all of the colors in another color scheme, but I forget where is it. Where is it in, because there are a lot of. Okay, next time I will show you. I find it and show you. Well, when you type the reserved word, Visual Studio shows you this word in different color. Well, and the very important notion of language is their identifier. When we write a program, we have to operate with different information objects. For example, variables or constants or any other values. And in order to distinguish them, one from another. All of these information objects are assigned with their unique name or identifier. For example, suppose that we want to write a program that computes the sum of two numbers. I show you this example on previous lesson. I can type here 2 plus 2 and output 2 plus 2. And we see on the screen that 2 plus 2 equals to 4. But imagine that, these values are fixed. I type it and I cannot change it without recompiling the program. If I run it, I see the result, but I cannot change these values. I cannot enter these values from the keyboard. But imagine that I want to write a calculator that computes the sum of two numbers that I enter from the keyboard. How to do it? We should declare in the program two numbers, this and this. For example, the number A and the number B, A and B. And these two numbers must be declared using identifiers. Identifier is just the name of some information object. And to compute these two numbers, of course, I can use identifiers just A and B. For example, if I want to compute not just the sum of two numbers, but, for example, the area of a circle. Do you remember the formula of area of a circle? Formula of the area. Area.
Which consists of P.
RP, R square and P, yeah, right. If I want, for example, to compute the area of a circle, I can create three, or maybe I should declare 4 identifiers for values. Area equals to pi times R, not 4, 3 identifiers. Pi, R, and area. This identifier I can create as not R, but radius. In C language, upper case and lower case letters are different. So these two identifiers will be considered as different identifiers. Radius with a small lowercase letter and radius with uppercase letter. Different identifiers. But also I can use another identifier. Even I can write the formula something like A equals to P times X times X. Yeah. The formula is the same, but it's hard to guess that this formula corresponds to the area of a circle, because I use identifiers with their general names A, B, X. It doesn't correspond to the area. What? P? Pi? Do you remember? Do you know the number pi? 3.1415. Do you know it? No. P. Pi. Do you know this number? 3.1415 and so on. This number is very important in mathematics. Pi means this. Pi means this. By the way, maybe do you know some other numbers? Not like P. Like P that like pi that are very important in mathematics. Other numbers. 27. Yeah, any number is important. There is one more number. I think you will work with this number in mathematical analysis. This number denotes E. It's not epsilon, it's E. There's number E that used in exponent, logarithms. It's 2.7 and so on. Two great numbers. Everybody knows that P and E. Well, if I declare some identifiers, I can write some expressions. And well, I skip these 3 slides. I come back to these slides on the next lecture. I want to show you the example in Visual Studio. To show it, I should say a few words about data types. And after I say it, I show you the example, how to compute this. And to declare an information object, we should declare a variable. And to declare a variable, we should use so-called data type. We should use a data type. I skip several slides. I show you just the main points. And again, I come back to the slides on the next lesson. And at this slide, you may see the general scheme of a variable declaration. First, you should write the type of the variable. Next, the name of the variable and 2 optional parameters, initial value and class of the memory. What is class of the memory we consider later. Initial value is just the initial value of this variable. There are just a few basic built-in types in C language. All of these types I write here in this diagram. But again, we discuss in details about this diagram on the next lesson. The most important types are int for integer valued data and float for real valued data. Chart for numbers, yeah, chart for numbers. About all of the types we discuss later. Just now let's use these 2 types, int for integer and float for real numbers. According to this scheme of declaration, to declare a variable of some type, I should write first type, and after that identifier. Type, identifier, and value. And after that, in the program, I can use these identifiers with their corresponding values. Well, let's write this example. Suppose that I declare two identifiers, two integer variables, A and B. Now A and B can be integer. What is integer number? Do you remember? What values we called integer? Integer. What are what numbers we called integer? Integer number. Numbers without fractional part. 0, 1, 2, 3, 4. Yes, and -1, -2, -3. Not 2.2. 2.2 is not integer. It's a real number. So integer, int, we can use only for numbers like 1, 2, 3, -1, -2, -3, 0. In this case, if I assign 2 to A and 3 to B, after that, I can compute the sum of these two numbers. A plus B. A plus B equals to 5. Well, let's do the same, but for this example, for computing the area of a circle. Area will be not integer, but the real number. To work with the real number, we should use another type that called float. Let's declare the area. We don't know the value of area. That's why I declare it without initial value. Let's declare P with it's enough. If in our example it's enough. And let's declare radius. Radius, for example, equals to. Very good. Very good. After that, when I declare these three variables, I can write computational statement. Area equals to pi times radius times radius again. There is no operation of raising in square to compute radius in square. I should type it 2 times. Okay. Now Yes, I can output the value of area. So I output the value of the variable area that I compute using this formula. Well, we get this result. Okay, very good that you remember the formula of area, but you do remember the formula for the length of a circle.
I D by D.
By D,
By D.
right? But what is D?
R plus plus. R plus R.
R plus R, or two times R, 2 times R, right? To compute the length, I should introduce a new variable, len. And write a corresponding formula. Len equals to 2 times pi times radius. After that, I can write another computational statement that length equals to len. Let's run the program, and we see the oops. Yeah, here because the radius is 2, the result is the same. Let's change it. Let's change it to 3. And now the result is different. Area is 28. The length is 18. Well, just as a simple remark that these two computational statements generally you can write in one cout statement. You can, after you output the end of the line, you can write it like this. Area equals to area, end of line, length equals to len, and end of line. And we will see the same on the screen. So these two lines can be output to the screen using one output statement, or I can do it using two output statements like this. Of course, it's better to separate the output and output your result step by step, line by line. Well, okay, suppose that I type here another identifier, radius. What happens? The Visual Studio compiler doesn't know what is it. Any identifier that you use in your program, it must be previously declared. I declare that I cannot use radius. You see that the development environment underlines this identifier with a red line. And also, if you try to run this program, you will see the message. Here it's in Russian, but in English it must be, it should be something like radius undeclared identifier. And also, if you For example, declare here red with a capital R. I told you that here the uppercase and lowercase letters are different. And these two identifiers, red with uppercase in uppercase and red in lowercase, will be considered as different identifiers. And if you try to run the program, you'll see again that the message that red is an undeclared identifier. Now the program is correct. Well, do you have any questions about it? No. Okay, here in this example, I assign values. I assign values for the variables when I declare it. On practice lesson, I think you consider how to input the values. Yes, so very good. It's seen, but I think other students don't know this. You consider how to input the values from the keyboard and how to build maybe a simple calculator that can compute some simple arithmetic operations.
Excuse me, boss.
Yeah.
So this stuff, this float area length line. Let's assume you just should like float area, or you just should like float pi equals to 3.415, rad equals to 3, and then you just come down and write the area equals to pi times length equals to, without writing it after the float. You still work. You have to.
Yes, I declare it once. I declare it. The line number 10, I declare it, and lines number 11 and 12, I use it. I don't have to declare it again. The declarative statement, it must be only one. I declare it, and after that I use it. Well, more questions about this simple program? What?
Each line you have
Yes.
at the end. I something this English.
No. This symbol. But not see out. Not see out.
I think you want to go, I should type CTRL and F5 at the same time.
Two options, Control plus F5, or you can just put, you can press this button, or Control plus F5. Well, we have 5 minutes to the end of the lesson. Well, again, I ask you to download and install the Microsoft Visual Studio on your laptops to have chance to work not only here in this room, but in any place where you have your own and you have your laptop. If you will have some problems with installation, you can ask your practice teacher, and he helps you to install Visual Studio. Visual Studio is free. You can find and download it from the Microsoft site, Microsoft page, and install in your laptops. Other questions? No. Next lesson, again, let me repeat. You will have 2 lessons. Tuesday, practice here in this room, 9.10, and Thursday, lecture. So we will meet on Tuesday. Maybe I'll come in the beginning of the lesson just to be sure that it's okay. And after that, we will have the lesson with the practice teacher. And we will meet on Thursday after the week. Well, now I stop sharing the screen. And also I stop recording.